Okay, so this was our last packet for AP Calc BC, so chapter 9, so third packet, so that was particle motion. So our beginnings here is just what are the three different motions that we have to be aware of. So we have our three equations: position, velocity, and acceleration. So with position, typically we are only going to be working in one direction, like typically horizontal or vertical. So if we have horizontal movement, we would just use x of t, vertical movement, y of t. We are also, because of it being a Calc BC topic, we'll also be working with parametric. And if we have parametric, then we will have both a horizontal and a vertical movement. So we would be given actually two equations if we were in parametric, so pair of equations, parametric. And then that would be for position. And then if we were to take the derivative of velocity, derivative of position, so x prime of t, that would give us our velocity. So then we know that if we want velocity, we would take the derivative of position, and that would give us our velocity equation. Zoom out here, sorry. So the derivative of position is velocity, or if we were in vertical, then it would be y prime of t is equal to v of t. Or if we were in parametric, then we would have it in x prime of t comma y prime of t. So we would take the derivative of position, right? And then also the derivative of our vertical position. So horizontal and vertical positions derivative would give us velocity. And this is the notation we would typically use for parametric. So we would group the two different equations that we have. It also, occasionally, they will use parentheses instead, so be prepared to kind of see it either way. So then the other one that we have is our acceleration. So acceleration is when we take the derivative of velocity. So the derivative of velocity, and that would give us our acceleration equation. And then back in our chapter 3 days, so mean value theorem, we had, when does average velocity equal instantaneous velocity, or average acceleration equal instantaneous velocity? So just as a reminder, right, we had that mean value theorem. So I'm just going to write that up here. So mean value theorem, this is from our chapter 3, where we would say like f prime of x is equal to f of b, and then minus f of a over b minus a, right? So that was our mean value theorem from chapter 3. So we're just using that same kind of idea, but we're going to apply it to our particle motion. So average velocity, so just that change in position over change in time. So we would do like xb minus xa over b minus a, right? So final position minus initial position over that change in time. And then our instantaneous velocity is what would be our derivative. So average acceleration would just be the change in velocity over the change in time. So our final velocity minus our initial velocity over that kind of change in time. Okay, so those are the three that we'll be working with. And again, we'll be working with it in either just function notation, meaning we'll be given just one equation, or parametric, so we would have horizontal and vertical motion both. If I were to take those derivatives, that gives me my velocity. So if I just have a function, it would be just x and x prime, or y and y prime. But if I have parametric, I would have both horizontal and vertical, and that's the notation we would use for that. And then again, average velocity, change in position over the change in time. And then instantaneous acceleration would be the second derivative, so that notation could look like that for parametric, or if it's just a single function. And then average acceleration, again, is change in velocity over the change in time. So this little box right here is all of our derivative relationships. So we need to make sure that we know these. And then we also have our integral relationships that we need to know as well. And then we'll hit on this one again. It's on the back side as well. But this is kind of a summary of pretty much just about every single equation or formula you're going to need to know. So I'll reference each of these again when we are on the back side because they pop up again. This is just like a nice little summary of everything we need to know, though. On that front page, they have easy access to it. Okay, so just a couple of things that we need to know, phrasing and their relationship mathematically to that phrase. So that's kind of that 1 through 13 here. So you may want to pause it first, kind of read through, or pause the video, read through these first yourself, and then come back on or skip forward, because most of you probably are familiar with this, especially if you were in physics or are in physics. Okay, so what do we need to know? So when we talk about something initially, so the beginning, that means when your time is 0. So these are going to be application problems, so we are looking for when time is equal to 0. Okay, we also have at the origin. So if something's at the origin, that means your position is 0. So if it was vertical, it would be y of t is equal to 0. When something is resting, that means your velocity is equal to 0. So you're going to see this one quite a bit, so make sure you pay attention to that. The other piece that is really important, because they usually ask this question a couple different times on the AP test, is about your particles, like movement. When is it moving left, when is it moving down, that sort of thing. And that's a movement, so whenever we're talking about movement, we're talking about velocity. So if your velocity is positive, right, so if you have positive velocity, then that means you're moving in a positive direction. So that could either be right or up, right? So if velocity is positive, then you are either moving upwards or you're moving rightwards. Okay. And then if your velocity is negative, so velocity has direction, so it could be positive or negative, then that means specifically then your movement is either leftwards or downwards, right? So if your velocity is negative, so I'm going to write it as less than 0 this time, then you're either moving downwards or you're moving left. And they're going to relate this to derivative graphs as well. So just as a reminder, if we have a velocity graph that is below the x-axis, that's what makes it negative, or if you have a velocity graph that is above the x-axis, that's what makes it positive. If you had a position graph, that's totally different. Then that's about slope, and we would have to look at that differently. And then number 6 is just kind of relating that same definition that we have over here of what average velocity is. So just saying it one more time. So your average velocity is just the change in position over the change in time, right? So your position change divided by your time change. And then instantaneous velocity is that derivative component of position, and that's when it's at a single moment or that instant in time. Okay. If the acceleration of your particle is positive or negative, then that's saying something about your velocity increasing or decreasing. So acceleration, remember, is the derivative of velocity, right? So if your velocity is increasing, right, velocity is increasing, you have a positive slope there, so then your acceleration would be positive. And if velocity was decreasing, you have a negative slope, right, so a negative slope, so then your acceleration would be negative. Okay, so they also oftentimes ask you about when does your particle change direction. So it's going to change direction if your velocity changes signs, right? And that was the intermediate value theorem. So for example, if your velocity went from negative to 0 to negative, it's not changing direction, it just rested, right? Just rested. So this is just a resting spot, so it rested. It didn't change direction, right? Because your velocity would be going left, took a little break, and kept going left, right? Did not change direction. So this is not a change in direction just because it hit 0. So what does it have to do? It has to go from like a positive to 0 to a negative, or negative, hit a 0, and then hit a positive, right? And it's possible it could be undefined, right? Like maybe, I don't know, some crazy thing was happening. Velocity goes from positive, did like a little undefined dance, and then went to negative. That would also give you a change in direction. So whenever the velocity happens to change signs, it has to, you know, hit 0 or some sort of undefined component, which would be really weird, but it could do that. And then you would have a change in direction. Okay, so speed. So what we call speed, so speed specifically is the absolute value or magnitude, so magnitude of velocity, that's also something that we will sometimes say. And usually when we are referring to magnitude of velocity, we're specifically referring to kind of the parametric component. I've heard it used with function as well, but typically it's with parametric. So speed does not have direction, it's just that positive version. So if velocity would say negative 10 meters per second, your speed would be positive 10 meters per second. If it has parametric form, so meaning there's a horizontal and a vertical, this is where that magnitude piece comes into play. So you would say, okay, there's my, my delta x, I'm just going to call it delta x for ease, and my delta y. So then that velocity, or magnitude of velocity is actually the length of that distance. So then that would be what our speed value would be. So this is just Pythagorean theorem. And then again, if that's given delta x, delta y. So if your horizontal was separated from your vertical velocity, then we would have to find that shortest distance between them, which would be Pythagorean theorem, and that would give us speed. So it's just in parametric form, speed is the distance from the beginning to the end, or Pythagorean theorem. Okay, and for 12 and 13, we'll see some problems for this as well, just to kind of make sure we know this. So velocity and acceleration, if they have the same sign, so meaning if they're both positive or both negative, then our speed is increasing. So if they were both positive, velocity and acceleration, so velocity and acceleration are both positive, speed is increasing. If they're both negative, speed is still increasing, just in like that negative direction. And then if they have opposite signs, so velocity and acceleration have opposite signs, then your speed is decreasing. Okay, all right. So that is just some definitions and formulas we need. And then this side is that piece, so I was telling you, like the integral component would be explained a little further. So these formulas in the back here are the same as on the front. So we're going to talk about these up here, so the integral ones. So when we are just integrating, so there are no limits, then this is just an expression for position and time. So meaning you would be given a velocity equation. When you integrated it without limits, you're just given a position equation, right? Okay. So if you have limits, so if you have like an integral that has a number value, so definite integral, then you know that when you integrate velocity, that would give you just x, right? And so then what you're going to get is the change in position. So change in position from A to B, or x of the final time minus x of the initial time, right? And so sometimes they call that displacement as well, but we tend to always call it change in position. So this is really important for you to understand that when I integrate velocity, that would give me position, right? So that would just be x of t. And then from A to B, so that would be x of B, whatever that value is, minus x of A. So that's just a change in position, right? Like how far I, moved from point A to point B. So then if I have a starting value, so like maybe I didn't start at the origin, then that is how I need to find my actual position, right? So my actual position. So that position equation, so this is where I started, right? So my starting position. And then that would be plus my change in position, which is giving you actual position, right? Keeping in mind that maybe the time didn't start at 0, so like maybe you started at, t equals 3, I was, at 4 meters. And so then just making sure that the information given aligns, right? So whatever that starting time is, and then what's the position at that particular time. So making sure you're thinking about that. Okay, and then finally the last integral is if we were to take that absolute value. So that absolute value of velocity from A to B, that is your total distance traveled over that time interval, right? So total distance traveled over that time interval. So That would be something like in a situation, like let's say that, I'm just going to be on a number line here, horizontal. Let's say I started at 1, and then each of these is, you know, so like 1 meter, 2 meter, 3 meter, 4 meter. So, so let's say that I started right here, so my starting position would be at 1, and I took 2 steps to the right, and then I turned around and took 1 step back. So my position, right, my position would be, I would be at 2. Let me just do at 2, like 2 meters or whatever. So that would be my position, right? Because I went 2 to the right, 1 back, and so I would be at 2. But my total distance I traveled would not be 2, right? Because I certainly traveled a whole lot further. So my total distance would be, I went forward to back 1, so my distance I traveled would be 3. And so meaning because velocity has direction, I need to make sure that I'm taking the absolute value of velocity if I want to know the distance I traveled. So that I know that when I went backwards at 1, I'm going to take its positive value to push me forward 1, right? So that it gets counted as a positive value. That's why it needs to be absolute value. Okay? All right. So that's that. Okay, let's go ahead and do a few examples here. So we can kind of make sense of some of this, right? Because that's a lot of information. All right, so for example 1, it says that a particle moves along the x-axis, so that its position is given by this equation here. So this is my position equation, and we want to find the velocity and we want to find the acceleration. So I know that in order for me to find velocity, I would take the derivative, right? So I would do x prime of t, right? And that would give me velocity. So that derivative then would be 2, so just power rule, right? So that would be 4t, and then minus the derivative of 3t is 3. And so then to find it at t equals 2, so then I would be looking for v of 2. I would just replace t with 2. Oops, I'm doing math at the same time I'm writing. So then that would give me 8 minus 3, which would be 5. So v of 2 would equal 5. And then they asked for acceleration. So acceleration, so I'm just going to do that. So I would take the derivative of velocity, and that would give me my acceleration equation. So the derivative of 4t minus 3 is just 4. And so then a of 2 would be 4, right? So the acceleration is not dependent upon time at all because it is a constant, so constant acceleration. Okay, so let's take a look at example 2. So for this one here, so it says a particle moves along the x-axis, so that here's its position, and they want to know when is the particle resting. So I know the particle is resting when velocity is equal to 0. So then I'm just going to go ahead and take that derivative. So then I'm just going to do power rule all the way across. So 2t cubed is 6t squared. And then the derivative of 21t squared is 42t. The derivative of 72t is just 72. And then the derivative of constant is just 0. And I want to equal this to 0. So I can solve this in my calculator or solve it by hand, but I know this is just a factored one, so I'm going to factor a 6 out of all of these. And then I'm going to factor my trinomial, so I'm trying to find values for 12 that multiply to 12, but will also work to give me 7. So I know for factors of 12 are 1 and 12, 2 and 6, 3 and 4. And so 3 and 4 will give me that 7, but they both need to be negative so that the product is positive, but the sum will be negative. And so then using that 0 product property, then t would either equal 3 or 4. And I don't give any units, but probably seconds or minutes on that. So the particle would be resting at t equals 3 or 4. Okay. All right, and then for example 3, so for this one right here, they're asking for you to find your total distance, right? That total distance. So we're going to be using the formula where we take its absolute value, right? And we only have function form here, right? So function form. So that total distance formula, this is the one we're going to use here, right? So total distance. Not this one, because I don't have two equations. I don't have an equation for x and y, just for x. So I'm only going to use that one right there. So that formula asked me to take the integral of the absolute value of velocity. So I need to take that derivative here. So I'm just going to do that off to the side here. So v of t. So I'm going to take that derivative. So that's just power rule. So the derivative of 4t cubed is 12t squared. And then negative 3t is negative 3. And then the derivative of 1 is just 0. So then my limits that I have are from 2 to 6. So I'm going to integrate from 2 to 6 the absolute value of 12t squared minus 3 with respect to t. And then I'm going to do that in my calculator. So if this was a calculator question, then like that's all you would have to have set up, and then you could do the rest in your calculator. So to do that in my calculator, see if we can see that okay. So I know I'm going to go to math, and then I want to go to the bottom of math. So that would be number 9. So I want to look at number 9 here. And then my limits are 2 to 6. And then to get to where, let's see if I can tilt that a little bit so you can see better. The absolute value. So it's a pop-up. Which one is it? I don't always remember. Let's try alpha F2. Yes, alpha F2. So alpha F2, so there gives me my absolute value, so number 1. Or the other way you can do that, so let me just kind of clear that out just to kind of show you another way. 2 to 6 is if you go to math, so the math button right here, and then just scroll over 1, so that's the other way to find it as well. Okay, so under math or alpha F2. And then 12x squared minus 3, and then with respect to x. So then my total distance traveled would be 820. And I don't know the units, but like meters or something like that. Okay. All right. That's that one. Let's take a look at this next one here. So example 4. Okay. All right, so for this one right here, so they're saying that the position of a particle at any time t greater than or equal to 0 is given by, so I have two different equations here, right? So I have x of t and y of t. So because I have two position equations, then that means I need to be using the parametric formulas. And so then they want to find the total distance traveled. So I can't use that same formula, right? Because I have two equations. I don't have one, I have two equations. So because I have two equations for my total distance formula, I'm going to be using this form of that total distance, right? So I have a x and a y, so this is the one I want to use, okay? So for total distance traveled, so we're going from 0 to 5, so I need to know x prime and y prime, so let me find those first. So the derivative t squared minus 3 is 2t. And then the derivative of y, so I'm going to bring down the 3, which will cancel, so that'll give me 2t squared. So there's my x prime, and then there's my y prime. And so then that total distance traveled would be the integral from 0 to 5. And then 2t squared, so x prime, plus, and then 2t squared squared, there's my y prime. Okay, so again, I'm using that total distance formula for parametric. So the square root of x prime squared plus y prime squared, right? So this is just total distance traveled, so the distance between the endpoints or Pythagorean theorem. So I'm going to simplify this just a little bit before I type it into my calculator. So I don't have this abundance of parentheses. So I'm going to go ahead and square that out. So that would be 4t squared, and then 4t to the 4th. And so that's what I would type in. So I'm going to go ahead and do that. It's pretty dark here. Let me see. I don't know if that made it better or worse. I don't know. Huh. Oh, it's just dark, people. Okay. So I would do math, and then it's at the bottom of math, right? Number 9. And then I'm integrating from 0 to 5. I don't know how to... Why is this so dark? Let me shed some light on it and see if that makes it better or worse. Maybe a little bit. Got a little glare. Okay. So we're going to go from 0 to 5. And then the square root. So square root. And then 4t squared or 4x squared. And then plus 4x to the 4th. And then dx. Okay, and so I would always want to be accurate to 3 decimals, so that would give me 87.716, and then whatever those units would be. And I don't need to write down units if they don't give me units. So if they specifically told me like meters or something like that, I would have to do that. Okay, and let's take a look at example 5. So example 5. And so this one right here, so this is asking for, or given velocity, so we're given our velocity equation, and they're asking us for the position of the particle at t equals 6, so at time t equals 6, if the particle was at x is equal to 1 at t equals 3. So this is our starting, right? So our starting value, so this is our starting or initial position. And they started the time at t equals 3. So our initial position is at 1 at t equals 3, and they want to figure out what is the position then at t equals 6. So this is where, if I want to find position, I need to do initial position, so that would be at 1, plus the change in position, right? Change in position, which is, in this case, from t equals 3 to t equals 6 of my velocity equation, okay? All right, so I have my starting position, and then plus the change in position from 3 to 6 of my velocity. And then again, I would just type that into my equation, or into my calculator. So I would have 1, because that's my initial position. And then plus math number 9 from 3 to 6 of 4 sine of x, close out those parentheses, plus 2 with respect to x. So then that would be my new position, so at negative 0.8006 or 0.01, right, if you round or truncate. So that means I would be to the left, right, to the left of where I started this time, okay? All right, there'll be one more thing here, last thing on this video, and then I will start up a second video. So for this one right here, that relationship between that velocity, speed, and acceleration, so that's going to reference this stuff right here, right? So if you have velocity that is like positive versus negative, you're going right, up, down. Acceleration is positive, velocity is increasing. Acceleration is negative, velocity is decreasing. If your velocity and acceleration have both positive or both negative, speed's increasing. If they're opposite inside, then speed is decreasing. Okay. All right, so all 4 of these graphs are velocity graphs, right? So these are all velocity graphs, and we have to state whether velocity is positive or negative. So is our velocity positive or negative, and is it increasing or decreasing? We also have to make a statement about our acceleration. Is it positive or negative? And then make a statement about our speed. Is it increasing or decreasing, right? So is velocity positive or negative? Is it increasing, decreasing? Is acceleration positive, negative? And then is speed increasing or decreasing, right? So that's what we're taking a look at. Okay, so velocity graphs. So because it is above the x-axis, right? So it is above the x-axis, then that means velocity is positive, right? This graph here, velocity is below, right? Velocity is below, so it would be negative. Velocity is below the x-axis, so negative. Velocity is above the x-axis, so positive, right? So that would be our signs for velocity, positive, negative. And then we also have to say if it's increasing or decreasing. So as I go from left to right, velocity is moving upwards. So that means it is increasing, right? So it's moving upwards, going uphill, increasing. Here, as I move from left to right, velocity is going downhill. So that means it is decreasing, right? So velocity is decreasing. Here, this velocity graph here, as we go from left to right, it's going uphill. So then that means our velocity would be increasing. And then finally for this one here, so velocity as we go from left to right is going downhill, so that would be velocity is decreasing. Okay. And then here's that definition part. So because velocity is increasing, that means acceleration has to be positive. Right? So because velocity is increasing, acceleration is positive. So right here, so because velocity is decreasing, acceleration would be negative. Okay, so same reasoning here. So because velocity is increasing, then our conclusion about acceleration is that it is positive. So the slope is positive, right? And then finally, because velocity is decreasing, then acceleration would be negative. So we're looking at slope, right? So acceleration is the derivative of velocity. We know derivative is slope. And so if I were to look at like the tangent lines here, they are all positive tangent line slopes, so that's why acceleration is positive. So again, so acceleration is the slope of velocity, right? Okay. All right, so what do I know about speed? So speed had to do with if they have the same sign, so these are both positive, then that means speed is increasing, right? And again, that's because acceleration was positive and velocity was positive. Okay. So right here we have that velocity is negative and acceleration is also negative. So that means speed is still increasing, just in a negative direction. Right? And so again, that's because velocity was negative, acceleration was negative. Whoops, that's just like a straight line, that's negative. So now it looks like a positive. Okay, so because they were the same sign, then that means that speed is increasing, just in a negative direction though. So just in a negative direction, okay? And then right here, velocity is negative, yet acceleration is positive. So that means they're acting against each other, right? So although velocity is negative, acceleration is positive, they're not working together. So because they're not working together, then that means speed is decreasing. Right, so they have opposite signs, so because velocity is negative, acceleration is positive, right? Opposite signs are working against each other, so speed would be decreasing. All right, last one for this video. So this one right here, so we have velocity is positive, acceleration is negative. So again, they are opposite signed, so because they are opposite signed, speed would be decreasing. Okay, and that's it for this video.